All right, let's start the class today. So good afternoon, everyone. Today we're going to start with arrays.
Sir,
If you
one
see
question
what's
asked in
written,
a pointer, sir.
yes, Shivraj, tell me.
Sir, what is the null pointer, sir? How it will be used in the program?
Yeah, a null pointer is a pointer to which you assign the value 0. Okay, how we will use it in the program, I will show you when we actually use the program. Okay, but null pointer is a pointer where you assign the value 0. Okay, so
Yes, sir.
I will, when I actually show you the implementation of a null pointer, at that point of time, we will see exactly how the null pointer actually works. So right now, a null pointer is a pointer to which you assign the value 0. Just remember that. Is that okay?
Yes, sir.
All right. So are you able to see my screen?
No,
Are you
sir.
able to see my screen? No.
No,
Okay.
sir.
No, sir.
Just, all right. Just give me a minute. Let me get my screen back. So while I am getting my screen back, uh, yeah, I think now you can see my screen. Are you able to see?
No, sir.
Yes, sir.
Okay, fine.
Yes, sir.
Good.
Yes,
So
sir.
let's start with this topic, which you are actually seeing it on the screen, and that is called as arrays. All right. In case you get logged out, just log in. In case you get logged out during the class, please log in. All right, log in back. Okay. So what exactly is an array, and what exactly is array related to? So let's begin. Okay. Let me just clean off everything. Yeah. So in the last class and previous to that, we learned about pointers, right? And we learned about the pointers and the concept of indirection. All right. Now, we basically learned about how you can access or access a memory location using another special variable, which is called as a pointer. So in this chapter, in this session that we are actually, going to start, we are going to talk about arrays. All right. So what are arrays? So arrays are collection of similar data items. Okay. What are arrays? They are collection of similar data items. What is the meaning of similar data items? Where we'll come to it. All right. And another thing that is important when we are studying array is that arrays are very closely related to pointers. Okay, they have a very close relation with pointers. So the reason I taught you pointers first is because there is a relationship between arrays and pointers. So if you have an understanding of pointers, then you can understand arrays and how the pointers are related to, how the pointers are closely related to arrays. Okay, so arrays are nothing but they are collection of similar data items. Now, let's go back. You all know how to declare a variable with a specific data type, right? Like, for example, an integer or a character. You all know how to declare a variable, right, with a specific data type. Now, in many cases, you have to declare a set of variables, okay, a set of variables that have the same data type. What does it mean? It means that when I'm declaring a single variable, this A is basically allotted a memory location, allotted a space in the memory. How much of space it is allotted? Only one space. Okay. Depending on what is the size of this, whether it's a 2 byte or something, only one space is allotted, which means that for a value of A, I can have only for A, I can have only one value. Only one value. Right. Now, what we can do is, suppose I need to work with 10 integer values, then I need to assign 10 different integers, int A, int B, int C, and then I need to work with all the 10 different integers. Now in C, right, in C we can declare declare a set of variables of the same type. What I'm trying to say is, suppose I have a need where I need to have four numbers, like say 1, 2, 3, 4, and all these four are integers, right? All these four are integers. Now, since they are similar data, that means, look at this, they all are integers. That means they are a collection of similar data items. Similar data items means they all are integers. So what we can do is, in C, we can declare a set of variables of the same data type collectively, and though that is called as an array. So what is an array? We can refer to array as a collection of similar, in the books you will find written as homogeneous. Homogeneous means similar. Heterogeneous means different. Okay,
Different.
similar
Yes.
data types. So suppose I have A. If A is a single variable, which is a simple variable, a simple integer, then this A can store only one value. Now, if I talk about an array, so if I talk about an array, so if I have an array which is called A, then this array will be something like this. This will have multiple memory locations. Why there are multiple memory locations? Because each of those memory locations, I can store an integer. So I can store something like 3, 2, 6, 1. Now there are four different values. Now an important attribute or characteristics of an array is that you cannot store data of different types. It has to be homogeneous. Okay, you cannot store, I cannot have like 3.2 and I can have an integer and I have a character and I have a double. I cannot store values of different data types in an array. An array will always store homogeneous data. So what is an array? An array is a collection of variables that are of the same data type. It's a collection of variables that are of the same data type, and each item, now these are items, okay? Each item in an array is called an element. So if this is an array, how many elements are there? 4. 3 is an element, 2 is an element, 6 is an element, and 1 is an element. And these are all elements of an array. Okay, and all these elements are referenced. Okay, are referenced in the sense, what is the meaning of reference? Reference means they are identified, right, by the name of the array. All right, and then they are stored in a set of consecutive adjacent memory slots. So if you have a memory something like this, if this is the way your memory is organized in your computer, and if you are declaring an array, then what happens is this: if there are 5 elements in an array,
Sir, your voice is breaking down, sir.
So you are not audible
my voice
properly.
is
Sir, you are
Not
not
audible,
audible
sir.
properly, sir.
Sir, not
not
audible.
audible. Okay, uh, not audible. Just 1 minute. Am I audible now, or is it the same
Yes,
problem?
Yes,
it's
sir.
audible.
Yes,
Audible.
sir.
Yes, sir,
Audible.
Audible?
audible.
Okay, okay, fine, fine. So what I was trying to say was, if you declare an array, so if I work with arrays, so if I declare an array, that means what is going to happen is, for a simple variable, when I declare something as int a, in the memory, if this is your memory location, so if I have int a and int b as two different integers, then if this is my memory, right, the chance is that one of the variables can be allotted here, so, and the other variable can be allotted anywhere, so it can come here. Or if I have int c, then this variable can be allotted here. That means there is no relationship between these three variables in memory. There is no relationship, they are allotted randomly, right? So a can be here, c can be here, b can be here. But if I declare an array, okay, I'll tell you exactly how to declare an array. But if I declare an array, and if I declare an array of 4 elements, that means this is the way by which I declare an array. So if I write integer a, it means that allot only one memory location. So if I write integer a in brackets, I write 4, this means that 4 memory locations need to be allotted, and these 4 memory locations will store the 4 elements of an array. Now, when these are allotted in the memory, a very important concept that these 4 elements will be allotted in consecutive memory location. Consecutive memory location means this one, this one, this one, and this one. There are 4 different slots available, and they will be allotted in consecutive memory locations. In case of the first scenario, they will be randomly allotted. Why is that? The reason is because this array is being referenced by a single variable, right? So if it is referenced by a single variable, if I store the elements in randomly, then it will be difficult for a to have memory locations of these random variables, the random location. So a can store only one, a can have only one left values. That means a variable can have only one left values. I cannot have more than one left values, because a needs to store 4 numbers here, 4 elements. That means a needs to have 4 different left values. But here, since those elements are stored in a continuous memory location, a needs to know the address of the first location. So address of, if this is 101, right, a will have the left value a101. That is the starting address of this memory location, right? And how does a reference or refer to the 4th value then? What happens is, if the size of an integer is 2 bytes, right, then it can calculate that this is 2 bytes, so the next, sorry, so this is 2 bytes, so the next memory address will be 101 plus 2, so that is 103. So if this is the starting address is 101, this address of the second location would be 103, the third location would be 105, the fourth will be 107, right? So it is easy,
Sir,
or I, yes,
sir, always continually fill the array position.
I'm sorry.
Sir, always fill the
Yes, yes,
position continually.
yes, yes. Arrays, the memory locations are always continuous. Remember that. It is continuous. Okay. So the reason why it is continuous is here. So if I have an array which is A, right, and the memory location, so what this A is assigned the memory address of this first memory location. So suppose this is 5, this is 3, and this is 2, and the address of this location is 101. This is the starting address. And if an array is of, say, integer type, then we know that integer is of 2 byte size. So this will be 2 bytes. This will be 2 bytes. This will be 2 bytes. That means my total address, if my address of this is 100, then the address of this will be 102. Address of this will be 104. Okay. So if the elements are organized, or if the memory locations are continuous, so if I know the 100, if I know the address of the first location, I can easily find what is the address of the third value. But if they are not continuous, then it is difficult for me to find the address of the third element. Just imagine, suppose I tell you that there are 4 values in the memory, and I'm giving you the address of the first value. So this is the first value address, and those 4 values are stored randomly. So I have here, I have 3, I have 4. Now you know the address of only this 100, the first value. If I ask you find out what is stored in the second element or the third element, you will not be able to find out, because you know only the address of the first, right? You will not be able to find out these. Why you will not be able to know? Because you don't know the address of these. You know the address of only one. But if I store them in continuous memory location, suppose I store them continuous memory location, right? So I have 1, 4, 2, and 3, and I tell you, look, here is the address. The first address is 100. Can you tell me what is the third element? Now you can know what is the third element. How you can know? you know that the size of each number which is being stored is 2 bytes. So if 100 represents the starting point, the next element will be 100, so plus 1 byte plus 1 byte. So that means 102 will be the starting address of the second element. So if I need to find out the third element, I will add 1 byte and 1 byte, 2 memory space here. So it will be 104. This will be the address of my third element. So only if they are continuously allocated in memory, this you can know the values by a single variable. So this is a very important concept of pointers, that pointers, when you are allocating memory for a pointer variable or for a array, all the memory locations of all the elements are arranged in continuous memory location. Okay, so how do you actually declare an array? So it's very simple. You have to specify the data type of an array, right? And then you have to give the name of an array. So here, suppose I give the name of an array as array underscore int. Then I have to also specify that what is the size of an array. Size of an array is the number of memory locations that will hold the elements of an array. So in this case, what is the size? The size which is given is 8. So as soon as the compiler gets this particular line in a program, what it does is it will allocate 8 memory locations continuously. 1, 2, 3, 4, 5, 6, and 2 more. 8. Now this is what is done when this line of code is executed. Okay, so everybody is clear with this much. Now here, everybody knows what is integer, right? The integer specifies the data type of an array, right? What is this? This is the name of an array. So this is the name of the array. This is the type that of data that is going to be stored in an array. Just remember that this has to be all homogeneous, which means that only the integer values need to be stored here, right? Or which will be allowed to store here. Then you have these brackets, right? These brackets, this is a syntax, but this pair bracket, which is used, right, to define the size of an array, is also called as array subscript operator. Array subscript operator. Okay, just remember that, just in case somebody asks you. So this bracket, which is used to define the size of an array, is called as an array subscript operator. Okay, so how do we use an array now? All right, now the point is I have the values in them. So I can say this array has like numbers. So let's say some random numbers, 8, 9, 3, 5, 4, 3, 2, and 1. So these are some of the values, or some of the integer values which I have stored in an array. Okay, now how can I access these different values? Now I have the name of an array, which is array underscore int, right? Now how can I access, say for example, this one? How can I access this value using this array name? Okay, now you can access the elements of an array, one after the another, right? So in order to do this, you need to use a number which is called as an index number. So the first element of an array always start with the index 0. Okay, you know what's an index, right? Every book has an index at the back. What is an index? An index is basically, a kind of a, suppose if you refer to a book, at the back there will be some word. Okay, suppose you are looking for arrays. So at the back of your book, array will be written, and along with that array, one number will be given, and that number will be the page number. So using the index, I can go to the page number and access that value. Sorry? Yeah, Jabez?
Clear, sir. Continue.
Sir, your voice breaking
Yeah.
down, sir.
My voice is breaking?
Sir, it's clear.
Yes, sir.
Yeah, okay, fine. I'll just wait for a minute. I think it could be a network glitch. It could be a network glitch at your end also. Are you able to hear me? All the others, are you able to hear me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay, okay. Don't worry, if in case you're having a network problem and you're not able to hear, you can always go back and look at the video which I will upload. So there you can get things if you have missed out. Okay, please mute your microphones. Right. So I told you that each of those array elements can be accessed by an index. All right. Now the index starts at 0. That means the first. Can you please mute? Jabez, can you mute your microphone? All right. Okay, fine. So the first element of an array will have the index 0. Now that is very important. Okay, the array does not start with the number 1, but it starts with 0. So the starting point of the array index is 0. Now this is important because when you are working with arrays, this is one of the mistakes that many people make. So the first element of an array is at index 0. This is at index 1, 2, 3, 4, 5, 6, and 7. Okay, so if I have to access the fifth element of an array, sorry, fifth element in the sense 1, 2, 3, 4, 5. This is the fifth element. What will be my index number? My index number will be 4. So how do I access my fifth uh, element? So if this is your array name, right? If this is your array name, if I write the value 5, I will be accessing the fifth element. So if I have a simple variable like a, right? How do I access the value of a? I can access directly using a. But in case of an array, since it has multiple values, I can access a single value by specifying this number here. This number is called as the index of an array. So if I want to access the first value, what will be the index value? The index value will be 0. If I want to access the last value here, the last number, what will be the index value? The index value will be 7. Okay, so index value starts from 0 to 7. So if you have an array whose size is 100, the index value, the first element of this array will start at index 0, and the last element of this array will end at index number 99. So if I want to get the last value which is there in the array, I'll have to use the index 99. So if A is an array, I have to use A99 to access this last value. Is this are you able to understand this? Is this okay?
Yes, sir.
Yes, sir.
Okay.
Sir, what is the reason
So
behind that? When always error starts from 0.
no, it's just how it has been specified by the compiler. The memory addressing always starts with 0, so that's why it is there. Okay, there's no if there is any reason I don't know of, but like you have the decimal numbers which start from 0, similarly I think the index starts from 0.
Thank you, sir.
Okay, fine. So we will see exactly how an array can be initialized. Okay, now for example, let's look at an array. So if I create an array like of a character, okay, I can create a character array. So if I have say an array something like this, char day, right, and I can specify the size as 7. So I have an array which has got 7. The size is 7. That means how many values it can store? It can store 7 values: 0, 1, 2, 3, 4, 5, 6, 7. Right? So if I want to access now say that just think that the array is blank. Right now there are no values in it. So this is similar to something like declaring a character C. Simple. So when you declare a character, you don't have any values which are just a memory location is allotted for you. So if I need to put a value inside this, what do? I write C is equal to 5. Now what happens? The value of 5 is inserted into this memory location. Similarly, if I have an array like this, what is going to happen? 7 memory locations are continuously allotted, but there is no value inside this. So if I want to put a value inside this, I can easily put a value I can write day 0 is equal to, say, Sunday, S. That's it, because it's a character, I'm writing S. So what happens, day 0 means this is the index number. Index 0 is the first location. So here I can put S, right? So this S will go here. Now, if I write this day 5, so which is the memory location which I'm able to access? 5 means 0, 1, 2, 3, 4. This is the fifth element, right? Fifth. So day 0 is S, day 1, day 2, day 3, day 4, and day 5, right? So 5 is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So let's say this is Friday. So this F goes here. So this is one way by which I can initialize the values in an array. But this is not a correct way of doing it, because imagine if I have an array, a large array. So if I'm declaring, suppose, an integer, right, A of, say, 1000 array elements, then how do I initialize the 1000 elements? I can't do one by one like this. I can do A0 is equal to 5 and A1 is equal to 10, but this is not the right way of doing it, right? There is another way of initializing the values into an array, and that is something like this. Okay, when you are actually declaring an array, at the same time I can also initialize. So I'm giving you an example. So suppose I have an int A and I'm declaring this array of size 5. So at the same time I can specify 5 values this way. Okay, I can specify the 5 values, and these 5 values will get initialized into the different memory locations, starting with the index 0, 1, 2, 3, 4. So this will be basically A0. This will be A1. Okay, so if you have 5 memory locations and you give only 4 values, then the last one will remain empty. That means nothing will be initialized there. So this is another way of initializing basically an array. But
It is
again,
the called dynamic method.
sorry,
It is called dynamic method.
dynamic, it's not dynamic as such, but along with initializing, along with declaration, I am also initializing the values. Okay, static and dynamic are different things. So it is not dynamic here. We are allocating static itself. So don't worry about static right now, because I've not told you the concept of static. But at this time of, declaring an array, I can also initialize together.
Excuse me, sir.
So
Just having a question, sir.
yeah,
Sir, if we stored F in day 5, so the data is gonna be stored in number 4 because it starts from 0.
you're talking about this.
Yes, sir. The upper part, the
Yeah,
day 5 you
yeah.
stored F, so
The
data is
day
gonna
0
stored in
is,
number 4.
so day 5 means 1, 2, 3, 4, 5, 6th place. So you mean to say, okay, where this is going to be stored? Day 5.
Yeah. The day 5, the F is gonna stored in number 4 because it
Sir, you
starts
have
from
written
0.
index 0 to 7. It will be 0 to 6 for 7. So
Yes,
yes,
sir.
that is
Oh
why
yeah,
I
yeah.
is
No.
Okay.
confused.
Okay. Oh, sorry.
Yes,
The
sir.
6, there will be 7. Okay, 1, 2, 3, 4, 5, 6, 7.
4, 5, 6, 7.
Okay, just leave this out. Okay, just leave that out. I must have added one extra block here.
So
Okay,
the F
fine.
is gonna be stored in number 4.
So if you do day 4, that means 0, 1, 2, 3, 4. You can store something here. Anything you enter here, E will get stored here. Okay, so what will
No,
be
sir.
the,
So my
yeah,
question
what
is
is the
that it
question?
starts from 0, na? If I enter day
Yes.
1, then the data is gonna be stored in 0 or not?
If you enter
Yeah.
day 1 like this,
Yes, sir. Yes, sir.
then
That's
this,
always
it will
day.
get stored here.
Okay, so got it. Yes.
Okay, because the first, just remember, the first memory location will have an index value 0.
Oh,
Okay,
yeah.
so if you want to store it in the first memory location, that means the first element will have index 0. First element, so this is element and this is index. So at first element will be stored at index 0. Second element, index 1. Third element, index 2.
Okay, sir. Continue. Thank you, sir.
Okay,
Thank you.
all right. Okay, so normally if you see here, This way of initializing an array works well. This way of initializing an array also works well. But when we talk about arrays, right, you will realize that there is a very important concept that we have studied earlier, that is looping. And for loops are one of the most easy and commonly used techniques of initializing an array, which means that rather than initializing the array this way, for example, if I have to take some input from the user, right, and put it inside an array, then it's going to be difficult for me to actually use this way or this way, because I have to write so many different codes, and each of these codes I have to write multiple number of times. Right here also, right, multiple number of times I have to enter the values here. So for loop is one of the ways by which I can, initialize an array, read an array, or access the all the elements of an array. So for loop is a very common technique, using for loops to initialize an array. Now I'm just going to write a simple program to show you how you can use the for loop to enter the some values into an array. So although you can use like custom, what you call the user input values, but we have not done yet. We have not done the scanf statements. So I'm not going to give you a user input value, but let's try and see how we can initialize the array using a for loop. So just go through this simple example, right, to understand that. So here I have stdio.h, and let's get over these main, and we'll just write a simple 2 lines code, okay, to do this. Let me initialize a variable I, and let's initialize an array. So let me write an array. Let it be a list having integer of how many numbers? Let's say 10. Okay. Now important thing is, since there are 10 memory locations here, if I want to insert the values inside those 10 memory locations using a loop, that means in one iteration I will insert one value, in the second iteration I will insert the second value. How many times the loop has to run? How many times the loop has to run?
0
The
to 9,
loop
sir.
the loop has to run 10 times. Okay, so we will run the loop from 0 to 9. 0 to 9 is 10 times, 1 to 10 is 10 times. So we will run the loop 0 to 9, because the first element, the index, starts at 0. So it will be easy for me to control it. So let's write the for loop, and everybody knows how to write the for loop. So I'm going to put the value of I as 0. That means the I value is going to start with 0, and I'm going to check that the value of I should be less than 10. It's very important. If you put less than or equal to here, then this loop will run for how many times? It will run for 11 times.
11
Okay,
times.
so it's very important what you put here. Because I have declared an array with size 10, if I run the loop for 11 times, there will be a problem. Okay, and then let's go and increment this. Everything's okay till now? Now what I'm going to do here is, now I'm going to take the first element. So let's take the first element. So my first element, list underscore int, that is my array name, right? And the first element is going to be the 0th element, right? That's going to be the 0th element. Now, rather than writing 0 here, what is the I value? In the first iteration, the I value in the first iteration is 0. So I will not write 0 here, but in place of 0, I will write I. That means with every iteration, first the value of I will become 0, then it will become 1, it will become 2, it will become 3, it will become 4, and I will keep on putting the values as and when this loop is going to run. So let's say I insert the value, whatever, say 1, okay, I plus 1. So when the value of I is 0, then I'm going to insert the value 1. And then what we can do is we can print f. We can print and see whether this is working fine or not. So how do you print the first element? In order to print the first element, I have to, let's write %d. So this is basically a format specifier, right? And let's give this, and what I'm going to do here is just print the values from an array. Now, how do I print the value from an array? I have to access the element of an array. So this is the name of an array, right? And I'm going to write I. That means with every iteration, the I value will change. So in the first iteration, list I int I value will be 0. What I will be doing, 0 plus 1. 1 will be stored into the first element of an array. Now that I will print here, because list underscore int I will, this I value will be 0, which will basically be the first element of an array. So this is going to be 10, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 10. This is how this list underscore int, this is how this array will be, allotted in the memory. So this element will be list underscore 1. Sorry, list underscore 0. This element will be list underscore 1. This will be list 2. This will be 3. So the index will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let me just close this program, return 0, and then close. All right. So now let's see what happens. So here, nothing is happening. There's just I am declaring, right? This, what is happening here? I have created an array of 10 memory locations. What I'm doing here, I have started the for loop. So the value, initial value of I is equal to 0. So what's going to happen here? List underscore int, this value of I will be 0. That means it is going to access the first memory location of that array, the first array element. And what it is going to do, it is going to take the value of I, which is 0, and it's going to add 1 to it. So the value 1 will be inserted into this. And now I'm printing this. So percentage %d is a format specifier, and I need a value. So the value is coming from here. So list underscore int I means I value is 0. So the 0, what is the value at 0 index? The value at 0 index is 1. So 1 is going to get printed. Now this loop is going to go here and check whether this condition is satisfied. What is the I value here? The I value here is 1 now, because we go to the second iteration. So when the I value is 1, this is satisfied. It comes here. Now I1, this I is 1. So it is actually accessing this memory location. What is this value? This value will be 1 plus 1, 2. So 2 will get inserted, and this program will keep running, right, till the last value is, this condition is satisfied. So when the I value is 9, it will be here. But when it goes to the next iteration, the I value changes to 10. Once it changes to 10, that means it will exit this loop. And what I have done here, I have initialized all the values inside this array. So all the elements of an array has been initialized. Okay, so by using a for loop, I can initialize, I can, do calculations, I can, do a lot of processing, which is, useful with arrays. So for loop is a very important tool that you use with arrays, because using arrays you can do a lot of things, right? You can do multiplications of matrices, you can do, you can store continuous values, you can, do a lot of processing. There are so many applications of an array, right? And for loop is a very, very important concept in programming, because they work very closely with an array. Now, how do I find the size of an array? That's an interesting question. Now, what is the size of an array here? The size of an array here is actually this. If I am talking here of that array that I have declared is an integer array, right? So if it is an integer array, and if my compiler is allocating 2 bytes for an integer, then each of these cells here is going to occupy 2 bytes. So you're going to have 2, 2, 2, 2, 2, 2, 2, 2, and 2. So you're going to have 2 into 10 times. So what is going to be the size of your array? The size of your array is going to be 20 bytes. Right. Now, how can I find the size of an array in a program? Now, there are 2 ways by which I can find the size of an array in a program. I'm not going to write the 2 ways of finding the size, but if you know the size of the data type, how can I find the size of the data type? The size of the data type can be found by using the size of operator, right? We have done this before. So there is an operator available in C called as size of operator. So if you give the data type, it will tell you what is the size which is allotted by your compiler to that data type. So if you write the statement, for example, size of int, right? Then this will give you the size of an integer that the compiler is allocating. Along with this, if you multiply this with your array size, right? So for example, in the last example that we saw, the array size was 10. Now the output of this statement will be the size of an array. Okay, now this is one way of doing it. There is another simple way of finding the total bytes of an array. Now another way of doing it is take the size of operator, and rather than writing integer here, write the array name directly. Write the array name directly. Okay, this will directly give you the size of your array. So if you look at the previous program, so in this case, how can I find the size of my array? So all I need to do is use the size of operator and write the name of an array, which is list underscore int, and the output of this will be the size of your array. So if your integer is of 2 bytes, it will give you 2 into 10, 20. If your integer is of say 4 bytes, then it will give you 4 into 10, that is 40. Okay, now many times what happens is, the reason why I told you this example of calculating the size of an array using this method, although this is very simple, right? But many times when you go for your interviews, right, when they ask you some questions in your interviews, one of the questions they can ask you, how can you find the size of an array without using the array name, right? So in that case, you have to use this concept. Just find out what is the type of that array and what is the total number of elements in an array. If you multiply these two, you will get the size of the array. Is that okay? Is it clear?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So
Yes,
today's
sir.
class we will end here, and tomorrow's class. Tomorrow we don't have a class. Sorry. So in the next class, I'm going to introduce how an array is connected to a pointer. What is the connection? What is the relationship between array and a pointer? So I will introduce that relationship in the next class. So for today's class, we are done. Yes, people have already started giving the attendance. Please give your attendance, and once you have given your attendance, you can